So, good morning, everyone. Thanks for being here. This is the first podcast that KITT4SME organized regarding standardization. And today we are here to talk about standardization in the manufacturing sector, adopting artificial intelligence. There will be a series of podcasts that will be organized by KITT4SME, thanks to the cooperation of other European projects. And then these podcasts will be shared on AI4 Manufacturing channel and on each project social channel. The agenda that we will have today will be a brief introduction of what we are doing right now, a presentation of the project that joined today our podcast, and then a briefly discussion about the standards adopted by each project with pro and cons, with procedures, methods, and suggestions that each project is using or used during its standardization task and activity. The main goal of today is here to discuss with you, with other partners about standardization in order to exchange our knowledge and experience, and also to try to promote the usage of standards in order to highlight why it could be useful to use standards when we are several companies that are working together. Holonix is organizing this because we are task leader of standardization in KITT4SME project. And as I said before, this is the first podcast of a series. We will organize 3 events about standardization. In this one, we are going to talk about manufacturing in sector adopting AI. In the second podcast will be about standardization in the circular economy sector, and the third one will be standardization and data management. So we will see this kind of correlation. This podcast will be shared on each project channel and also through AI4 Manufacturing channel. In all of these events, about 8 different projects will be involved. First of all, let's see what we mean with standardization, starting from the International Organization for Standardization, ISO. The definition, a standard is a document established by a consensus of subject matter experts and approved by a recognized body that provides guidance on the design, use of performance of materials, products, processes, services, systems, or persons. So the idea is that the standards provide rules, guidelines, or in general, some characteristics that some activities should have in order to achieve the results. So the standardization, let's say that that is the final point of a flow that starts with research, with industrial support, and reach the innovation thanks to the usage of standard that brings stability and security also for investing. The main benefits that as KITT4SME we found adopting standards are that technologies work smoothly and reliably together. Moreover, we could also use provide economies of scale. It could be also useful for research and innovation, and it keeps the markets open. Now we will go deeply inside in the projects that are involved in this podcast. Today we have KITT4SME, TRIC, COALA, and RARE projects, all projects under Horizon 2020. And now I will start with the presentation of KITT4SME. KITT4SME, it's a project that started in October 2020, and it will end next year in March 2024. We received about 8 million of funding, and 2.5 million were dedicated to fund actions with SME through open calls. In fact, we are now running the second round of our open calls. We are about 18 partners from 8 different countries in Europe, and the consortium is made by 4 digital innovation hubs and 4 internal pilots that work in manufacturing sector. This is the geographical distribution. So as you see, we have many European countries involved in our project. And KITT4SME started from a survey. We made a survey among several companies in the manufacturing field in order to test their artificial intelligence adoption and readiness. And we tried to rely our survey on 5 pillar model that are digital and smart factory, data strategy, human resources, organizational structure, and organization culture. So the idea was to test the usage of artificial intelligence in these several pillars for these SME interviews. And these were the results that then create the idea of KITT4SME. So about 39 companies interviewed, and nearly half of the companies didn't have any kind of artificial intelligence solution. So the idea was to create a platform in order to support and push also companies using artificial intelligence to show all the benefits they could achieve using these kind of technologies. In fact, KITT4SME is a platform that pushes to its limit by offering to external actors through also open calls in order to populate its marketplace, to expand its visibilities, and also the adoption of all the artificial intelligence that we are offering inside our project. The KITT4SME targets European SME and mid-caps in order to provide them a scope tailor and industry-ready hardware, software, and organizational kits in order to use artificial intelligence in daily activities. So we cover this entire flow, like preparing data, developing model, packaging model, validate it, deploy the model, and use the model. In KITT4SME, we have 4 pilots in manufacturing sector. One is in injection molding sector, one in quality system sector, the third one in precision and tool sector, and the last one in electrical equipment sector. They have different problems, and we found for them different solutions, and all these solutions are achieved through the usage of artificial intelligence. So, for example, as problems, we had high human effort, defects in individuation, tweezer irregular surface, low reconfigurability, and for each problem, we found a specific solution, like human-machine mutualism, data augmentation, vision system, shop floor anomaly detection, and all these solutions are achieved through artificial intelligence. In the second part of our presentation, we will see in KITT4SME as well as in the other project how all these solutions were achieved also through the usage of standards. Now I will leave the stage to the second project that is joining us today, that is TRIC. And so please, I will leave the stage to them in order to present their project.
Okay, thanks, Serena. Thanks for the invitation for this interesting event. So, TRIC is a project which is focused on the product data traceability information management by blockchains, interoperability, and open circular service marketplace. So in the end, here in the title, there is the objective of the project we will see in detail, but the idea is to collect the sets of information for the traceability and the future digital product passport by blockchains, and to offer the related services in a marketplace which is dedicated specifically to SMEs. The project started in May 2021 and will last 42 months. So we are just in the middle of the project, and next review meeting will take place on November 2023. So the project involves 31 partners of 11 countries, and as you can see, there is a significant presence also of public institutions. First of all, the Italian Custom Agency in the representation of the European Custom Agency, but we have also public bodies such as Enea, Politecnico of Milan, CNR in Italy, Sintef in Norway, the ITF in Germany, because it is absolutely necessary to define the standards necessary to collect the data for the future digital product passport and in general for the traceability of the product. Next slide, please. So the objective of the project is to create the infrastructure and all the enablers necessary to release 6 basic services, which are the traceability of the production per each lot and the related preferential certification of origin for the custom agencies, the circular assessment, the product environmental footprint, the health protection compliance, the social and ethical assessment, and in the end, there is also a pilot to exploit artificial intelligence to leverage all these standard data in order to verify the false green claims and to fight against greenwashing. Next slide, please. So the final goal is to release by a user interface which provides the consumers all the information as regards the traceability of the production and its impact and certifications, all the information necessary to make informed purchases of textile goods. Next slide, please. Okay, we have 2 pilots, and if you can click, Serena. Okay, we have 2 main pilots. The first pilot is focused on the traditional textiles and starts from the raw material collection with Schneider Group. Then we have Mark and Fieldy for the transformation from raw material into yarn, and Piacenza for textile and clothing production, and then the recycling will be carried out by Mark and Fieldy. We have a parallel pilot in the workwear, which is carried out by Filidea in Turkey. Then we have the transformation from the yarn into fabrics by Marina Textil in Spain, and then we have Trotustex, which is a company of the Grassi Group, which transform these goods into clothing for workwear. But Trotustex is also the company which, at the end of the life of, will collect the workwear, which will be sent back to Mark and Fieldy for the recycling and the second iteration, which will be carried out using partially recycled fibers. We have also a small pilot in the food with the support of the Cyprus Consortium in Sicily. Next slide, please. Okay, the idea is to save the data which are usually sensible in a private blockchain, which is based on the Hyperledger fabric, and to save the certifications in a public blockchain, which is based on Ethereum and provided by the Quadras Foundation. The basic idea is that all these data are collected in a standard model, which is compliant with the present legislation and hopefully for the future digital product passport, which we will see later, but to keep them private, while only the certification will be provided by the public blockchain and available for the brands which are selling the goods on the market. Okay.
Okay. Thanks Alessandro, for this presentation of TRIC. Now I will leave the stage to Caterina from COALA project.
Thank you. COALA is a project dedicated to the development of a vocal intelligent assistant to support manufacturing workers, both for the management of manufacturing process like quality control, for example, and for training the new workers to learn how to do their job. The project started late in the 2020 and it is going toward its end, that is planned for September 2023. We have 3 internal pilots that are really representative of different manufacturing process, both for discrete process industry that are Piacenza for textile and clothing, Whirlpool for household appliances, and Diversey for chemical products. The consortium is of 14 partners from 5 EU countries, Germany, Greece, France, Italy, and Netherlands. And the coordinator is the research institute from Germany named Viva. Please. Okay, the COALA solution is a human-centered solution that has in its focus the development of a user-friendly and cooperative digital intelligent assistant, exploiting the concept of crew, creating a crew with the human and the artificial intelligence, and consists of the composition of trustworthy AI components with a voice-enabled digital assistant as an interface for the main task. The graphical user interface is just a fallback for managing complex information that cannot be spoken, for example, like schemas or other type of pictures that are not suitable for a vocal assistant, but is just a fallback that is present to manage this type of situation. The idea is to, okay, sorry, objective 1. No, please. I already recapped. We have 4 main objects. The first is to reduce the number of quality incidents in manufacturing in order to provide interactive guidance to solve the quality problems. Then to reduce the time needed for on-the-job training of workers in manufacturing. This is a very huge problem that is resource time consuming, because there is the need of a lot of time by expert workers to train young workers in order to be effective to manage their task. Then we have another objective, the number 3, that is mainly a research objective to overcome barriers and reduce skepticism regarding the use of voice-enabled digital intelligent assistants, because, as you know, in manufacturing context where blue collars are used to perform the activities manually, relying on their own know-how, own intelligence, it is very difficult to introduce the use of AI. Then, as a consequence of objective 3, objective 4 is to improve competencies of blue-collar workers in managing AI opportunities, challenges, risks, and the shop floor. It is an awareness process to be developed. Textile production, the main objective of the Piacenza use case is to support on-the-job training of new machine operators, reducing the time and cost of machine operator trainings, maintain the workers' autonomy versus the unquestioned execution of instructions, and exploit and spread the concept and solution. So this is the main objective. Next. Detergent production, Diversey use case to support towards the optimum configuration of the production line, increase efficiency of production and reduce change over time, capturing the best practice and transferring them between manufacturing lines, And tacit line manager knowledge capturing, formalize and transfer to co-workers. Again, behind the line, there is the need to train other workers for this type of manufacturing. Please. White goods production. The Whirlpool use case is focused on the quality control procedure and the use of analytics tools. So to adopt a predictive quality strategy, to link quality control of the finished product with design stage and shop floor, and to reconfigure its production line and facilitate root cause analysis. So here the idea is to use the digital vocal assistant as a team member to support quality procedure and to check and exploit all the check quality procedures.
Thanks, Caterina. So we had also an overview of KOALA project, and now I will leave the stage to RARE representative that are here today. Thanks.
This is me. Hi, my name is Enes Benashur, and we are coordinating. I'm from Fraunhofer IWU, and we are coordinating the Rare Square project with the title of Human-Centered Reconfiguration of Production and Value Chain in Fast-Changing Scenarios. And as you can see, our project is just in the beginning of the project duration. So we started in December 2023, 2022, of course, sorry.
Yes.
There's a typo. And our project will end in May 2026. And we have about 8.4 million funding from the Horizon Europe program. So we are not in the Horizon 2020, we are in the Horizon Europe program. And we are 22 partners from 8 different countries. And our project structure is that we have one mini demonstrator to make some fast track testings of the software solutions, and 4 main demonstrators coming from highly diverse sectors. And in the end, we want to, or we have the aim to have an ecosystem demonstrator to roll out the developed solutions to more than the 4 demonstrators in the project. What's basically the challenge of our project? So it's a part of if a drastically short-term change of the market demands coming up, or a disruption of the value chain caused by crisis will pop up. This could be political pandemic or some natural catastrophes and stuff like that. Then usually the traffic lights, we call it, the traffic lights from the value chain switch to red, and the production has to stop. And basically from that point on, we want to fasten up the process to switch back those traffic lights to green. So this is our concept, using specific strategies and tools that the production companies are able to react on those disturbances and to fasten up the ramp-up phase for the production of new products or slightly changed products. So basically, as I said, we want to help to switch back those lights coming from the value chain and each single workstation to green to fast up the ramp up. And for that reason, we have some key pillars in the project. And the first key pillar we see, which is highly important, is that we have an early detection of those upcoming issues, which means we want to use some internal data sources, some external data sources, and connect them together in a AI-based early detection tool to give some prognosis of upcoming issues and the influence on the production or on the manufacturing side. Then we need to support the decision makers on multiple levels of the hierarchy to give them some more information about what is the impact if I change some of the production or workstations or value chain partners and stuff like that. And to give accurate information about that, we need a system level digital twin, which includes again internal data sources and external data sources coming from the value chain, which includes some of the quality processes of the production processes, the intra-logistics, but of course the extra-logistics as well. And with that system level digital twin, we need to simulate the changes in the manufacturing, so the reconfiguration of the system, to give out the decision makers some of KPIs which are adjustable for specific indicators like economic or ecological indicators, so that the decision makers have a higher base of information to decide accurately which is the best way to react on this disturbance. And in the end, the last step is the implementation of the reconfiguration of manufacturing. And for that reason, we need some tools to detect the qualification gaps inside of the manufacturing side or the company. And of course, coming from that gaps, we need some upskilling tools to train the workers to the changed workflows. And for that reason, we want to use some mixed reality trainings. And for all of these different parts, of course, we need some standardized data, standardized interfaces, and secured ones. And all of those different key pillars we want to demonstrate in 4 different use cases coming from representative sectors, and roll them out in the strategic objective 5 for the co-creation platform, which is for the ecosystem of the European companies. So basically, if we have a detailed look in the 4 pilots, so we have 1 pilot coming from the so-called roommates. Roommates are reprocessing units for medical devices, and the partner we are working with is a manufacturer of those roommates, and he makes the installation and rental services for example, hospitals which need to build up new capacities of reprocessing departments or stuff like that. And for them, the high challenge is that the units need a high modularity to fulfill the customer needs and the national standards and regulations. And for that reason, they need a fast reconfiguration of the existing modules, but as well, they need a fast reconfiguration of the production of new ones. So it's basically split it up a little bit, but they have to have a high flexibility in their product. The second use case partner is from the forming of car body parts and production of dies. And they have the high challenge that they have a growing demand of models with a same global production volume. They have high quality standards with practically zero defect manufacturing and high optical standards for the products in the end. They have a lot of production on short notice, and they need a shorter time to market to be better than the other car body manufacturers. Then the third pilot we have in the project is one partner which using injection molding for the production of child hardware, and they have the big challenge that they often have an unavailability of raw material, and this can be over a long period of time. So they need to change the or exchange the raw material with recycled material. They often have sudden changes in the product demands, and as well they need to change the designs on short notice. And of course, internally they have a lot of interruptions of the production lines, and they have to reconfigure their manufacturing site to react on those disturbances. And the last pilot in our project is a lathing of customer individual contact lenses. So each single contact lens is completely one product, a single individual product, and they use for the production of these highly specialized lathing machines. So for that reason, a rapid change in the production is not possible at the moment because of a lack of connectivity, and they need solutions to overcome those issues to get a flexible and highly automated production line. And for that reason, we have to develop some solutions for that point as well. So as you can see, we have four different highly diverse use case partners, and we try to help them in fast reconfiguration of their production.
Okay, thanks. Thanks for also for this presentation. So now we had a detailed overview of all the projects that are joining today. And now we are going to the second part of our podcast, that is the one related to standardization. So we saw at the beginning what a standard is, and now very briefly we will show which standards are used inside each project and which pro and constraints the consortiums are finding, and also the initiatives that they are taking in order to make some standardization activities. I will start from KITT4SME. Here we put a list of the standards that are mainly used by the partners in the consortium. As you see, KITT4SME, as you remember, it's a technical project because we are developing several technologies based on artificial intelligence. So the standards that are mainly used are standards related to developments like JSON, MQTT, HTTP, OPC UA. So, and this is a list that resumes all the standards used by the consortium. Then we wanted to highlight also the participation of the partner in some standardization committee. As you see, like all the partners are joining favour Foundation, W3C Foundation, Linux Foundation, and ECMA and ISO Foundation. Then we have some other partners that are joining other committee. The idea inside our project is it's to try to cooperate with this standards committee. And in fact, the main goals in standardization we have in KITT4SME are these three. The first one is to make the work related to the data model public and have our data model accepted as a smart model, because all the project is built on our smart data model because the KITT4SME is a platform, so we had to build consistent model, and thanks to the participation of several partners in favour Foundation, we submitted the KITT4SME data model to favour Foundation, and it was accepted and recognized as a smart data model. So now once you will go to favour Foundation website, for example, you will find also the KITT4SME smart data model as an example of a data model using artificial intelligence. Then we wanted, as I said, to improve the participation in standardization bodies and to promote our data model as well as all our activities. For this reason, we joined HS Booster Services. This could be a useful initiative also for all of you, because HS Booster is a free service promoted by the European Commission. They make some open calls very often, and as KITT4SME, we submitted our intention to be part of this service. We were accepted, and in fact we joined this service that consists to be in touch with a standardization expert that is suggesting us some activities, some standards that we could use in our project to promote also to the partners that are not using standards the usage of them. And the third one is what we are doing right now. The idea we had on how to improve their thoughts about standardization was to organize events with other projects, and for this reason we organize this first podcast, and we will organize the other two. So this was very briefly the standards used in KITT4SME project and our goals. To recognize something we did in our project, and we did it with our data model, and to be in touch with some expert, and I'm here also to suggest you to use the HS Booster service, and then to discuss and exchange knowledge and experience with the podcast. Now it's the time to Trick to tell us what they did or some suggestion.
Okay, thanks, Serena. So, as regards Trick, we have a deep involvement in the topic of the standardization, because the 5 certification which we have seen before, plus the one exploiting artificial intelligence to detect the false declaration, are focused on specific topics which are ruled in some cases by standardization. For first, the preferential certification of origin to support the traceability and to demonstrate the traceability to the custom agency. This is clearly based on the World Trade Organization rules and on the specific customs rules, which are based on the definition of the product and the production by specific standardized codes. And therefore, we have to follow the standardization, and the service provided is already compliant. For circularity, we are making an analysis and investigation about the potential standards to adopt, and we have defined in the project our proposal, because the certification of circularity is not yet defined by European Commission, and therefore we have to provide our own position in the project. For the product environmental footprint, we make reference to the PEF, which is defined by European Commission and therefore is a standard, as well as for the hazardous and chemicals and consumer health protection, where we have many rules and standards to follow. First of all, the REACH regulation by the European Commission. As regards the ethical and social assessment, there are many standards, and in the project we will make reference to the ISO SA 8000 standard. Therefore, already there we are following a precise standard to collect the data. The Trick data model is aligned with the current standards, as we have seen, specifically for the PCO, but on the second side, for the digital product passport, we will see in the next slide. So finally, the trick data are also protected by blockchain and are ready for portability between different blockchains. This is very important in order to demonstrate the reliability of the data and the fact that they are not able to be changed in a second time to provide false declaration about the green claims. Next slide, please. So a few words about the digital product passport. So this is a document which will become mandatory following the European eco-design legislation, and will be released by the final producer of the goods which will be sold to consumers. But as you might imagine, it must rely on the data provided through the whole value chain from the raw materials to the delivery of the final product. As regards the textiles, the delegated acts to define the contents are under development and will be released by the end of this year or in the first month of 2024. And Sistema Moda Italia with Euratex, they are working with the European Commission on this document. But mainly, the data provided for the DPP should collect evidence as regards the traceability and the provenance of the goods, the footprint, the durability, the warranty, the compliance document, the classes of performance and the durability, and the substances of concern. As you might imagine, in a fragmented sector like textile, it is necessary to collect all this data by each supplier and by each sub-supplier in order to put the brands in the position to release a reliable DPP to the consumer. Probably the DPP will be released by QR code, which will be read by the smartphone in order to provide a direct access to the data. Next slide, please. So this is the idea. Therefore, the important fact is that this information should be standard in order to put the consumer in the conditions to understand the performances of the goods and to compare between different goods. Because at present, there are more than 230 eco-labels present in the European Union, but on the basis of a survey by the European Commission, more than half of these labels are not supported by a concrete collection of the data and a precise data model and the scientific evidences. So this idea to develop the DPP hopefully will support the consumer to have only one reference standard information as regards the green performances. Next slide, please. Okay, so our solution is aimed to provide trustful data for the DPP, to collect them into a single server protected by blockchain, and to provide a guideline to follow as regards the data model, the semantics and the structure which have been defined during the project and are constantly aligned with the ones of the digital product passport. Next slide, please. So we provide a contribution as regards the data model standards, because in some cases for the digital product passport, the data models have not been defined yet. While they are there as regards, for example, the traceability and the path, or the chemical and hazardous materials which are used in the production, for some other certifications, such as the circularity, such as the ethical assessment, the Commission has not defined yet the standard, and the project has provided a position paper in order to provide also an indication as regards this, specifically as regards the granularity, which should follow the lot of the production in order to be reliable and clearly putting in link the final product to all the components necessary to produce it. The data management is also another factor, as well as the legal framework, because the protection of the sensible data and the publication of the certification, as we have seen, exploit two different blockchains in order to be also compliant with the GDPR standard. Okay, next slide. So we are collecting a very complicated set of data, which are in line with the ones of the DPP. So if you can see here with the red dots, there is a clear matrix and exploitation of the same sets of data in order to collect the ones for the DPP in vertical, and in horizontal you can see the certification provided by the TRIC project and that are available for the certification bodies and for the brands. Final slide. Next one. Okay. Before. Okay. So what is important to understand is that the standards are cross useful. What I mean is that, for example, the traceability standard should be exploited also to support the other certifications, such as the circularity assessment, such as the PEF, such as also the health protection and ethical assessment. This fact is specifically related with the granularity. Let's make an example. If we collect all the traceability data for a single lot, these data are obviously in relation with the circularity, and therefore we can provide also a circularity assessment based on the same set of data. But this set of data can be used also for the calculation of the product environmental footprint, because as you might imagine, they contain the phases of production, and on the basis of the phases of production, you can make a calculation of the footprint, and you can make also a check if the declaration as regards the PEF are reliable or not. So the same is for the ethical assessment, because if the facility is ethically assessed and accepted for the specific regulation as regards the ethical and social assessment to which the DPP will make reference, this will also mean that the product which has been produced in that facility is ethically assessed. So as you might imagine, it is absolutely important that all the data necessary for the future digital product passport make a reference to a single backbone, which is the traceability, and then on its basis you can exploit this backbone to add the additional data necessary for the other certification. So to conclude, the standardization is absolutely important, and now it is object also of the discussion within the European Commission as regards the digital product passport for textiles in the decrees which will be published by the end of this year. But it is also important because the cross standardization is mandatory in order to create a set of information which put the company in the position to save time using the same standards, and also the public body in the position to make cross checks in order to verify the green claims and to fight against the greenwashing. Okay, so I try to be very concise.
Thanks, Alessandro. It was clear. Thanks. Caterina?
Yeah. About the adoption of ethics standards, the COALA project uses a reference platform, the AI4EU platform, in order to demonstrate with the Y engine. The Y engine is the AI engine in order able to understand and process the questions that the vocal assistant receives, in order to have and guarantee a transparent use of digital assistance in manufacturing to fulfill the aim of giving best practices on the factory shop floor. Then again, to contribute to these standards that are pretty new, because the use of vocal assistant in the manufacturing domain is at its beginning, we need to turn them into a success story or lesson learned for the development of future trustworthy digital assistants. COALA worked a lot to promote our results toward ethics experts always exploiting the AI4EU platform and the demonstrator of the project. And then the final aim of all this job is to trigger or to directly contribute to standardization or regulation activities in this field that is in a continuous evolution. Next slide, please. Okay. Then, of course, we used some IT-related standards and we exploited everything was defined under the ISO standards. For example, the V3C as best practice for web development, the OASIS 21 as best practice in structured information standards for open collaborative development of a business specification, the OMG as best technology and engineering practices for software system and business modeling, and the open group of OMI and ODF standards. Next slide. Pros and cons of standardization for trustworthy AI. Of course, the pros are faster line reconfiguration, standardize the reconfiguration process of a production line for individual products by capturing the best practice with cognitive advisor and by disseminating best practice with the help of a digital intelligent assistance. The benefits are mainly on the optimization of manufacturing processes for fast reconfiguration of the production line. Operators can request advice, explanation, and other information via the digital assistant. In this way, we optimize production speeds, reduce bottlenecks, and reduce time pressure caused by downtime, and also the cognitive workload of workers are lighter in solving unpredictable complex production like management tasks. Next. Then again, one of the main aim of COALA is the training of workers and managers for managing production lines. If we are able to standardize somehow the know-how, the tacit knowledge of multiple experienced operators of the same production line, defining again best practice collection during training and during production of running and production line according to different operator needs. In this way, we will have big benefits by these standardization activities for the reduction of the time of training novice workers, managers, and so on. Then another big benefit is the AI-assisted quality control. Standardize the quality control based on statistical quality, defining best practices during training, during production, best practices collection of quality of products, processes, and worker performances. In this case, the main and tangible benefits of these standardization activities is the reduction of errors, optimization of quality of product, and the optimization of shop floor system and management. Next. Of course, every activity has some drawbacks, and in this case, our drawbacks is represented by the limited adaptability to different sectors and scenarios. To manage this type of processes by vocal assistants, we need to manage complex multi-company project systems, to think about strategies not only for individual companies, but also for dynamic business systems, and to adapt to different worker education and the skills in using digital systems that are depending on national, regional regulation and practices. These conditions create a barrier for the scalability of the system and to the effort needed to create a system that fulfills the needs of a specific factory. Then we need to cope with unsuited aspects of business. For example, we need to capitalize on growth opportunities from some sectors, and this is a problem to manage budgets and other business issues, to adjust the ups and downs in economic condition at market level, to meet target customer needs, to cope also with AI general distrust and acceptance, and to address the social issue for the preservation of jobs or consequent reduction of salaries versus the AI as a replacement of humans. All these aspects of the business are represent barriers for the development of this type of intelligent assistants. Please. Then there are specific ethical and privacy issues. For example, to adapt to project standard to the different natures and needs of a single solution, company have to comply with specific markets and regulation. The first one is about transparency based on the nature of the data and the level of sensitivity based on individual scenarios and sectors. So we need to manage both the transparency of data along the value chain, but on the other side also to protect the company know-how and the sensitivity of the data, of the business data. Then we have to manage also the data privacy and its sensitivity level. For example, the law doesn't allow to track workers and to measure somehow their performance at their job place. But we manage this issue collecting data in an anonymized way in order to analyze them in aggregated way without reconnecting with the identity of the worker. Then we have again the company know-how preservation and the data source preservation, and also the need to evaluate the training of the new workers. That is the only case in which we are able to reconnect the data with the identity, but this reconnection can be done just by the education institute that is collaborating with the company to train the new worker.
Thanks, Caterina.
Welcome.
So now we have the last project about the pro and cons. Please.
Good morning to everyone. As said before, Rare Square project is still a young project, started just last December. So we are still in an initial phase. We're dealing with standardization. So with a preliminary study and overview of the available standard and current situation for example, the 4 use cases sectors, and with also the possibility to study and understand which is the situation for other standards that could be used and considered in the next phase of the project. This first phase see that is needed to allow a fast transition, for example, from one sector to a compatible adjacent sector that, of course, has to be carefully identified. And so to obtain all this information, we had meetings with the use case partners and the other partners of the project. So next slide, please. For what concern the standard that could be of particular interest for which are the objectives of the project in during the proposal, we considered, for example, the ones that are included in these three categories. For example, the interoperability of product data definition, considering standards in this category could allow to move towards a constant growth and progresses based on the collaborative effort between the companies that can communicate more easily. Or, for example, of course, the one in manufacturing, that having this kind of standards could allow to have a common language to share information about the product change, the production chain, and so to facilitate the exchange of information, of technical information. And also the one for the visualization that are fundamental to allow to easily share, for example, 3D data, also with customer or partners in manufacturing. Of course, as okay, thank you. No, okay, that's good. To next slide. Furthermore, we also consider the applicable standard for the development of the digital twin and AI standards. That's these are just a few examples that maybe also during the other projects you had the opportunity to deal with. And so these are just a few examples to have some tips for the next activities of the standardization for R square. And this is also because AI is constantly growing in these recent years. So it is important to have has basis standards that are also being developing right now. So they are quite young standards. So it could be also useful to study this kind of standards to give to international or also national standardization organization some important conclusion about these standards and their pros and cons and their weaknesses or strengths. So next slide. Thanks to the constant sharing of information with the use case providers and the other partners, it was possible to obtain almost complete picture of the standards used in the sector of the use case providers. So I just put the standards that they shared with us. And this is fundamental to understand which are, of course, the standards to take into account for the sector transition. And also, so next step for these activities that are ongoing is to understand which are the standards for the adjacent sectors. For example, the one that I reported on the right are the one that the use case providers suggested to us. So to understand which are the steps necessary to the use case provider to jump in in these other sectors in a fast way, thanks to, for example, the the digital twin, for example, developed during Rare Square project. So okay, no, thank you. So since this study is just an initial phase, it is still ongoing. It is not finished yet, and further meetings and discussion with the technical partners are expected in the coming days. And here I just reported, for example, some standards adopted by the technical partners for the communication. So let's say that we would like to identify advantages and disadvantages of the standards for communication for AI and digital twin, discussing with these topics with the partners. And of course, we are going to see during the meeting the other adjacent sectors to focus on, and which are the standards and certification needed for the transition. So this is necessary to be able to develop the final goal of Rare Square project. So for now, we don't have more detail, but just this quick overview that is still ongoing, and hope to have some important results about this topic. So thank you.
Thank you. Thank you very much. So we have a very interesting presentation, not only of the project, but also how you are approaching these standards initiatives. For sure, we saw several approaching because, for example, KITT4SME is a project with only some months left while RARE is a project started in some months ago. So we have different approach and different initiative, but I think it was useful and interesting to get each other knowing what we are doing. If you want, we have some minutes for free discussion. In the meanwhile, while maybe you are thinking some questions, I would like to summarize what we will do. So we will share this podcast on each project joining channels, and then on AI for Manufacturing channel. AI for Manufacturing is a community that was born in a European project and that now is going to be every day larger, and so we are sharing information on these also in this way. Regarding the other events that the KITT4SME is going to organize, we will have two other podcasts, one in June and one in July. The first one, as said at the beginning, will be about standardization in the circular economy sector, while the second one will be standardization and data management. I don't know if anyone would like to add something. Anyway, I would like to thank everybody for joining today, and also for the preparation of the material. And I hope that we could continue our cooperation, not only about the standardization, but also about other topics, in order to share our experience and knowledge.
Thank you very much.
Thank you.
Thank you. Thanks a lot for the invitation.
Thank you. Okay, so if we do not have any other question, we will send you in the next days the podcast so that you can use it as you prefer. And remember to tag all the projects that joined today in your channel so that we improve and enlarge also our project community. Thanks everyone for being today, and have a nice week.
See you, Serena.
Thanks, you
Thank
too.
you.
Thank you.
Bye.
Bye.
Thank you.
Bye bye.
Bye.
Bye bye. Bye all.
Bye.
Bye.